So in this video, let me help you to solve a problem with the help of Kirchoff's voltage law. Probably what they will ask you is that you will be asked to find out the current that is flowing in any one of the branch that is given in a circuit similar to that given in the board. In that case, Kirchoff's voltage law will help you to solve the problem much easier compared to that of any one of the method. So, when your circuit is much complicated in the sense you have got many number of branches in the circuit, in that case, it will be difficult for you to solve the problem and find out the current in each branch. Probably you can go for Kirchoff's voltage law to solve the problem if it is a complicated one. So one example is solved for you. You can follow the same method to solve the other problems. So this is the problem given to you. You can see the circuit consists of two branches, two voltage sources with many resistance interconnected to each other. Now I am going to apply Kirchoff's voltage law to solve this problem. How am I going to do that? Follow me. It will be made much simpler for you. Okay. So there are certain rules to solve a problem related to KVL. What are the rules is that how should I understand or how should I determine whether there is a potential rise or potential drop in any circuit? For example, let me take a voltage source. Okay. The longer line will be positive, the shorter line will be negative. In that case, let me move from A to B. So when I am going to move from A to B, you can see that when the ending potential, the ending value, the ending line, whatever it is, that will be the potential of this battery. Suppose it ends in negative, you can see that I am going to move from A to B. It ends in negative, so the potential is minus negative. The reverse case is true. So if suppose I am going to have a battery like this, a cell like this, I am going to move from A to B, so the ending line is positive, whereas it is a longer line which is positive. So when it is ending in positive, the voltage will be positive. This is the first rule what you have to follow. The second rule is, suppose I am going to take a resistance. This is one resistance and let it be A to B. I am going to move from A to B. Always the current entering direction is positive, the leaving direction is negative. Okay. So when I am going to move from, assume it is to be entering point is positive, I am moving in one direction. In that direction the entering point is positive, the leaving point is negative. In that case, so the leaving point is negative, the current, let it the current here be I, the resistance is R, then the potential drop according to Ohm's law will be equal to minus I into R because it ends in negative. Okay, the reverse case is true. Suppose I am going to take the resistance like this, it is A, B, I am going to move in the opposite direction, current is flowing in the opposite direction and I am moving from A to B. When I am moving from A to B, it is taken as positive and negative, but the current is flowing in the opposite direction. When the current is flowing in the opposite direction, it ends in positive. So what you will have here potential to be, it is a potential rise which is equal to plus I into R. Okay. So these two things you have to remember while solving Kirchoff's voltage law. Let me take the same example what is given in the previous case. Now the same example is taken, the same problem. Let me take this problem and solve or frame the equations according to Kirchoff's voltage law. Let me do that. Okay. So now for this, the first I am redrawing the diagram again. Okay. So here 10 volts, 5 ohms, here 2 ohms, 3 ohms and 6 volts. Now first what you have to do here is you have to identify how many mesh are present in the system. How many mesh? Mesh is a closed loop where a single current is going to flow. No diversion of current is present, only one current is going to flow in the circuit. So in the given circuit there are two mesh. So two mesh are available. I have to identify the currents in the two meshes. So you have to identify the current that is flowing in the two mesh. So first let me take the current that is flowing in the first mesh be I1, the second mesh be I2. Okay, always assume the current in clockwise direction. This is much important. Assume the current in clockwise direction. For easy understanding, for easy solving, always assume the current in clockwise direction. So I have to assume both the currents I1 and I2 in clockwise direction. Now next step what I am going to do here is I am going to write the loop equation for the first loop, for the first mesh. So for easy manipulation, let me name the branches. Name the branches. So I am going to name the branch. Let this be A, B, C, D, E and F. I have named the branches. Now I am going to write the Kirchoff's voltage law for the first branch, for the first mesh and the second mesh. Let me do that. Okay, I am taking the first mesh. First mesh is taken into account. So the first thing is that this is my first mesh and current I1 is flowing in this direction, I2 is flowing in the both are taken in clockwise direction. So I1 and I2 both are taken in the clockwise direction. You can see here. Now this is 10 volts and this is 5 ohms and this is 2 ohms. Okay, now I am writing the nodes. Okay, so A, B, E, F, A. This is the mesh that is identified. First what I am going to do is I am going to move from A to B. I am going to move from A to B. If I am going to move from A to B, you have got a single resistance to be present. And in that single resistance, current I1 is flowing in this direction. I am going to move from A to B. So what will happen? You will have a potential drop. So potential drop will be, according to Ohm's law, it is equal to I into R. Here it is 5 ohm. The current is I1. So you will have minus 5 into I1. So it is ending at plus minus. It is ending at minus. So minus 5 into I1. Next, take your B. Let me erase this. Okay. So next take your B to E. So when I am going to move from B to E, you got a resistance like this. One current is flowing in this direction and the other current is flowing in the opposite direction. Okay, so now B to E I am going to move. Entering point of B is positive, leaving point is negative. So when I am going to write with respect to I1, the current that is coming like this is ending at minus. So it is minus, the resistance is 2, minus 2 into I1. But when I take with respect to your current I2, it is entering at negative. It is moving in the opposite direction. I am moving from B to E, but the current is going in the opposite direction. So the polarity is ending at positive. You will have here as plus 2 into I2 according to according to Ohm's law. Yes, so this is my next equation. Now let me go for E to F. E to F, you do not have any elements to be present, so that could be avoided. And next one is I am moving from F to A. So let me erase this. I am moving from F to A. Okay, from F to A I am going to move. F to A I am going to move. So when I am going to move from F to A, so what you have got here is you have got a potential or a battery, a cell is present, and I am going to move from F to A. So F to A, the entering is negative and the leaving is positive. So the leaving polarity should be taken into account. Since it is positive, this value will be equal to plus 10, that is equal to 0. So according to Kirchoff's voltage law, the sum of all the potential rise and potential drop in any closed loop will be equal to 0. That is what I have written for the first mesh or loop. Next I go for the second mesh. Let me take the second mesh. So second mesh is taken into account. I will do this very quickly. Resistance, another 2 ohm, then 6 volts. So 6 volts, 3 ohm and 2 ohm. So here the current in this loop is I2, here it is I1, and this is my branch names. Now let me quickly take it. The mesh value, the mesh branches are B, C, D, E, B. Okay, this is my mesh branches. First I am going to move from B to C. When I am going to move from B to C, I got a 3 ohm resistance and current I2 is flowing. So both are in the same direction. I am moving from B to C. Current is also moving in the same direction. Hence it is negative. Minus 3 into I2. Next, from C to D I am going to move. When I am going to move from C to D, you have got a 6 volts. That 6 volts is ending in C to D, it is ending in negative, so you will have minus 6. Okay, from D to E I am going to move. D to E no element is present, so that is equal to 0. From E to B I am going to move. From E to B if I am going to move, you can see that two currents are encountered by the 2 ohms. One is I1 and the other one is I2. When I am going to write with respect to I2, I am going to move from E to B. Current is moving in the same direction as I am going to move. E to B I am going to move. Current I2 is also flowing in the same direction. Then it is negative. So you will have minus 2I2. Then with respect to I1. So I1 is flowing in the opposite direction. I am moving from E to B. I1 is flowing in the opposite direction. So when I1 is flowing in the opposite direction, that will be positive. So plus 2 into I1 is equal to 0. So this becomes the KVL equation for the mesh 2. On adding up, summing up all the values, what you will have here is 2I1 minus 5I2 minus 6 will be equal to 0. This is my second equation. Okay. So now what I am going to do here is I am going to solve these two equations. So finally I got two simultaneous equations. The first simultaneous equation is you will have minus 7I1 plus 2I2 equal to minus 10. The second simultaneous equation is 2I1 minus 5I2 is equal to 6. So solve these two equations. You have got many methods to solve. Find out the current I1 and I2. So on solving these two equations, you will have your I2 to be equal to 0.709 amperes and your I1 is obtained to be 1.22 amperes. You can do with your calculator or you can do any one of the method. Find out your I1 and I2. Now if they ask you to find out the branch currents, so through 5 ohm resistor if you take, the current I1 is flowing. So your 5 ohm resistor, the current is 1.22 amperes. Okay. Through 3 ohm resistor, you can see that the current I2 is flowing. So your current will be equal to 0.709 amperes. Now through the 2 ohm resistor, you will have two currents to flow, that is equal to I1 minus I2. You will have it to be 1.22 minus of 0.709. So if you are asked to find out the individual branch currents, you have to obtain in this method. So this is about how to solve a problem with respect to Kirchoff's voltage law. Similarly, if there are 3 loops or 3 mesh in any circuit, you have to write 3 equations. You will have 3 different currents and you have to solve the 3 equations to find out the currents I1 and I2 and I3. Then finally you have to find out the branch currents. Okay. So this is about Kirchoff's voltage law. Thank you.